Hello everyone, myself Mrs. Janvi Darshan Raut, lecturer in Electronics and Telecommunication Department of Pravin Patil College of Diploma Engineering and Technology. In this video, we are going to learn our third chapter, that is digital modulation technique. In digital modulation techniques, the digital system consists. In a digital communication system, the source to be transmitted is discrete both in time and amplitude. The digital information carrying signals must be first converted to an analog waveform prior to transmission, and at the receiving end, analog signals are converted back to the digital format before presentation to the end user. The conversion process at the transmitting end is known as modulation. The receiving end is known as the demodulation or detection. In baseband pulse transmission, the input data is represented in the form of discrete signal, or you can say line codes. These signals are transmitted over a communication channel. However, the digital passband transmission, which is the digital input data, is used to modulate a sinusoidal carrier. These signals are transmitted over a bandpass channel. The example of bandpass channels are microwave radio link or the satellite channel. So here is the functional block diagram of digital communication system. In this digital communication system, we are having first input, that is binary sequence, or you can say binary transmission, then source encoder, channel encoder, modulator, physical waveform channel, then demodulator, channel decoder, source decoder, and the final output. Factors that influence digital modulation is low bandwidth efficiency rate, performs well in multipath and fading, high spectral efficiency. The performance of a modulation scheme is often measured in terms of its power efficiency and bandwidth efficiency. The power efficiency is the ability of a modulation technique to preserve the fidelity acceptable bandwidth efficiency ratio of the digital message at low power levels. Good BER performs at the slow SIR under condition of co-channel interference, fading, and the time dispersion. Now, advantages of the digital modulation techniques. First, the effect of distortion, noise, and interference is much less in digital signals as they are less affected. Second, digital circuits are more reliable. Third, digital circuits are easy to design and cheaper than analog circuits. Fourth, the hardware implementation in digital circuit is more flexible than the analog signal. The occurrence of crosstalk is very rare in digital communication. In the signal is unaltered as the pulse needs a high disturbance to alter its properties, which is very difficult. Signal processing functions such as encryption and compression are employed in digital circuits to maintain the secrecy of the information. The probability of error occurrence is reduced by employing error detecting and error correcting codes. Spread spectrum technique is used to avoid the signal jamming. Now, there are having some various types of digital modulation techniques. First is phase shift keying (PSK), frequency shift keying (FSK), amplitude shift keying (ASK), on-off keying (OOK), the most common ASK form, quadrature amplitude modulation (QAM), the combination of PSK and ASK, continuous phase modulation (CPM) method. Now, what is coherent and non-coherent detection? In the coherent digital modulation techniques, we have to use a phase synchronized locally generated carrier at receiver to receive or to recover the information signal. The frequency and phase of this carrier produced at the receiver should be perfectly synchronized with that at the transmitter. The coherent techniques are complex but guarantee better performance. What is non-coherent detection? In non-coherent detect techniques, no phase synchronized local carrier is needed at the receiver. These techniques are less complex, but the performance is not as good as that of the coherent techniques. Thank you.